Alright, welcome to Academic Diaries class. So today we're going to be treating number system, and this is a part of general mathematics, elementary mathematics for university students. So in number system, I need to first of all make an introduction of what number is. We say that number is a mathematical object. So a number is a mathematical object. I can say it's a mathematical tool. So if I don't use object, I can use tool or tool used for expressing. Used for expressing or comparing physical quantities. So I said here, a number is a mathematical object or tool used for expressing or comparing physical quantities. So the knowledge of this, the idea of what number is, gives us account of what happened before number was discovered. Years before now, it used to be when they want to talk about numbers, some persons might count by saying 1, 2 and many. So some will do 1, 2, 3 and many, or they use strokes to indicate that this is the number of what they have. And if peradventure it goes missing or goes below what they stroked, they know that yes, something has happened. So this is the way it was until the Hindu-Arabic, the Indians and the Arabs, they came together and invented what we call number today. And mostly number was done using the fingers. So as we progress in this course, you understand, you see, you get a clear understanding of what I'm talking about. But generally, in overview, we know that there is what we call the natural number system. Alright, so there you have it. I forgot my duster. So under numbers, I've seen some people, whenever they are talking about number system, they are thinking of it under number base. No, we have what we call the natural number. The natural numbers or natural number system. It's under this natural number that you have base of numbers, number basis. And under this number basis, you have things like, under this number basis, you have things like base 10, which you call the decimal, base 2, which you call the binary, base 8, which you call the octal, and base 16, which you call the hexadecimal. So all these things, you can go to my YouTube channel and check. I've treated number basis, the decimal, the binary, the octal, and hexadecimal, how to go about it, both the division and everything. So I'll still make more videos on this to illustrate the past questions. So this is where you have the natural number. We say that number base is simply illustrates grouping of numbers in bundles or counting of numbers. How you go about counting of numbers? Are you using base 10? Are you using base 2 or base 8 or base 16? So number system does not have to do with number base, because number base falls under natural numbers, and you know that natural numbers are the counting numbers. So, and these are simply, we say that natural numbers are the set of numbers from 1. They have beginning, they start from 1 and run to infinity. So I can have 2, I can have 3, I can have 4, to infinity. So to positive infinity. So which means that negative numbers are not natural numbers. So natural numbers are the counting numbers. So if I know this, it goes to tell me that anytime I have things like the even number, under this natural number, that's where we have things like even number, the even numbers. I will say that these even numbers are simply numbers of the form 2n. That is numbers that can be divided by 2, or numbers that when you multiply any value by 2, those sort of numbers or those set of numbers is what you call even numbers. So this still falls under natural numbers. So things like 2 times 1 is 2, 2 times 3 is 6, these are even numbers, 2 times 4 is 8, these are even numbers. So under these natural numbers, we have also what we call the odd numbers. And these odd numbers are simply the set of numbers which are in the form 2n minus 1. So for example, you say odd numbers are a set of numbers that cannot be divided by 2. Or you say they are a set of numbers 2n minus 1. So odd numbers are a set of numbers 2n minus 1. For example, if I do 2 times 3 is 6, minus 1 from 6 is 5, and 5 is an odd number. If I say 2 times 7 is 14, minus 1 from 14, 13, and 13 is an odd number. So you need to know that. So under these same natural numbers, okay, let me clean this. Under these same natural numbers, we have number systems. We have types of natural numbers like prime numbers. Prime numbers. I would say that prime numbers, these are numbers that can only be divided by 1 and itself. An example is 3. There is no other number that can divide 3 except by 1 or 3. 2, the same thing. So 5, 7, 13, 17, and so on. So those numbers that if you clearly look, you see that the only thing that can divide them is itself or 1. Those are natural, those are prime numbers. So if I know this, we even have we have here, you can see that what I have here over 1 is more like a rational number, because every number is a rational number. Every natural number is a rational number, provided you can see here every natural number is a rational number, because every number you see, even when you talk about 3, is standing all over 1, and anything divided by 1 is that thing. And we know that we get to rational numbers. So this is the first type of number system, which we call the natural numbers. Is represented by the symbol n. So the second type of number system is what we call the integers. But yes, let's go with integers. But before I go to integers, remember I said natural numbers are the set of counting numbers, which means I can't come and start counting something and I say 0, 1. It's wrong, it's not proper. So when I want to count something, objects or things around me, I normally start with 1. That's natural number. But the Arabs in 628 AD invented the addition of 0. They introduced this 0. So when I add 0 to natural numbers, we say that that set of number is what we call whole number system. So whole numbers are the set of numbers, the set of natural numbers with 0. Or we say that whole number, we can say that whole numbers are the supersets of natural numbers, while natural numbers are subsets of whole numbers. So we can say that natural numbers are subsets of whole numbers. So the addition of 0 to natural numbers gives us whole numbers. So whole numbers are a set of numbers from 0 to positive infinity. Alright, now that I know this, let's talk about the next type of number system. So we know two now, natural number and whole number. So the next type of number system is what we call integers. Integers. If you remember in your secondary school days, they normally represent this with something like Z. In some textbook, you see it this way. So we said that integers are the set of negative whole numbers. Let's say -1, 0, and positive whole numbers. So we can represent this on the number line. So such that if I have this now, 0 stands as the neutral point. While this is the negative part, this is the positive part. So we say that integers are the set of negative whole numbers, 0, and positive whole numbers. So you need to know this. As we start solving example, remember this is introduction to number system. As we start solving example, we delve deep. We're going to delve deep into applications of these integers. See how it can go. See how we can tackle examples under each of these number systems. So, but the key thing you need to understand is that anytime you have negative numbers, let's say -3, -2, -1, 0, 1, and so on and so on, from negative infinity to negative whole number to negative infinity to positive infinity. These are all what we call integers. So if you look at it very well, we've gotten natural numbers, whole numbers, and integers. So let's treat what we call rational number system. Remember, we are not doing an example, we are trying to introduce this number system for today. When it's time for example, I like to make use of our book class, more of the book class than the board class. So for rational number system, we say that rational numbers are the set of numbers with numerator and denominator. I said rational numbers are the set of numbers with numerator and denominator, whose such that, so we are set of numbers with numerator and denominator, whose denominator such that the denominator cannot be equal to 0. You know that in second semester we'll be doing something called function, and it is wrong for 0 to be at the denominator because 0 multiplied by anything is 0. So if you multiply something by 0, it gives you 0, which means that there is nothing you are getting for 0 when you have to divide something by 0. So that is why we don't allow 0 to be at the denominator. So for that reason, rational numbers are all those numbers, or we can say that they are the ratios of integers. We can say that rational numbers are ratios of integers. What I mean is that this can also be 3 over minus 1. You see it? This is a positive whole number, which is an integer. This is a negative whole number, which is an integer. And you see that the both of them can exist. So we can say that they are ratios of integers. So provided that the denominator is not 0, we can see that rational numbers can include integers. They can also include natural numbers. And you know that by right, by default, see what I said? If I have 3 all over minus 1, you see, this is positive whole number, this is negative whole number, and this is an integer, this is an integer. So ratios of integer is what we call rational numbers. And I now said that by default, every number you have, 1, 2, 3, 4 to infinity, every number by default, even your whole number, every number by default is a rational number, because all of it can be divided by 1, and anything divided by 1 is that thing. So if I divide all these things by 1, it has a numerator and a denominator, which accounts for what we call rational numbers. Alright, so we go to the fourth type of number system, which we call the irrational number system. The irrational. Remember, rational number will normally represent rational number with Q like this. While irrational numbers we normally represent it with Q complement. So this is for rational numbers, number system. While this one is for irrational number system. So we say that rational numbers, we can also define rational numbers as set of numbers with reoccurring decimals. If I do 2 over 3 or 3 over 2, whatever it gives me, this will give me 1.5. This should give me, if I come and do this should give me around 0.5 thereabouts. So if I check this, watch, yes, okay, let's leave it this way. If I check this, you see that whatever I get for these two runs into a form that can continue, that can progress. It can progress. So for that reason, we say that set of recurring decimals are rational number. But irrational number, when I do, for example, root 2, you can see that this root 2, what it will give me will be such that I have something like 1.41442, as in when I think it is stopping, it changes. So the recurring decimal is not definite. So we can say that irrational numbers are the sorts that you have. They are the sorts. They are a set of numbers with this radical. We call this radical. And whenever you have such a radical, if it's just one of it, we call it the quadratic sort. Let's say I have this here. We can call this a quadratic sort. While if I have something of this nature, let's say I have Q here, or let's say I have 5 here, we can call this a cubic sort. And these are sorts in its basic form. once there is no perfect square, inside this radical, we say it's a sod in its perfect or in its basic form. But assuming I have, for example, 9 times 2, and this is root 18, you can see that this is not a sod in its basic form because of the fact that it has perfect square and it has this basic sod. So this is the same thing as saying 3 root 2. So for sod, we have a video on sorts. If you subscribe and you check the video, you check the channel, you see that there's a video on sorts, but that's not what we are treating today. So the idea, the concrete idea you need to get from this is that those set of numbers that gives you non-reoccurring decimals, it does not stop, it does not terminate. Non-terminating decimals is what we classify as irrational numbers, represented with the symbol q raised to power c. So in some textbook you see it as even, they represent it sometimes as f. So but this is what we know it's popularly for. So the next type of number system we'll be treating this morning is what we call the real number system. The real number system. Real number represented with r. You and I know that nobody on earth knows the next number after 0. In some books you see it, they will tell you it's 1. But notice that even if you check, you will see that there's still 0.1. And when you say 0.1, you can still see some places where if you check very well, you see 0.001. Like when you are doing measurements in your physics, our first topic, measurements under physics, you see that when you're doing things like micrometer, screw gauge, vernier calipers, you always have varying what we call a degree of accuracy. So you see it changes. So nobody knows the next number after any number. So we simply say that real number is like the major or the father of all the number systems after complex number. Why am I saying that? Reason being that this real number accounts for every number you can think of. Every number you can imagine is what we call real number, and it accounts for what we call, you will still see us when we are solving questions under this. It accounts for things we call association, associative properties, distributive properties, commutative properties. So under what we call binary operation, this helps us. You will still see that this helps us account for what we call identity. We have things like multiplicative identity, addition identity. Things like when you use 0 to multiply any number, you definitely see that there is no multiplicative identity for 0. While when you use 1 to times any number, you see that you always get 1. So it's a multiplicative identity. While if you use 0 to add any number, you will see that you always get that number. So 0 has an additive identity. So these are the kind of things we will treat under this real number. But just know it that real number is simply talking about the set of all the numbers you can think of, or the set of all the numbers found on the number line. Remember that integer talks about just the negative, the 0, and the positive, and all are whole numbers. But real number accounts for both the decimal, the fraction, everything. That is what real number is. So we can say that real number are a set of natural number, whole number, integer, rational and irrational numbers. So with that said, let's treat the last one. So notice that I've taught you natural numbers, whole numbers, integer, rational, irrational, and real numbers. So the last one, which is the 7th one, is what we call complex number. And please, the next time somebody talks about number system, do not confuse it with number basis, because number basis is found under natural numbers, because we are talking about counting and we make use of number basis to count. If we are not counting in tens, can we count in decimals? Can we count in binary? 2. Can we count in octa? 8. Can we count in hexadecimal? 16. So for that reason, we treat the last one, which is what we call the complex number system. And all these number systems, we are going to solve question on it, treat it each one individually. When you talk about irrational numbers, when you talk about complex numbers, all those arguments, and the rest, but the Morpheus theorem and all those applications related to sets. So induction theory and all that, we'll do it in our next class, which we are going to tag problems on number system. So alright, for the seventh one, which we said is a complex number, this complex number we represent it by, if we have a C, we put an indication or we put a stroke inside it. So we said that complex number is simply a set of numbers with real and imaginary parts. It's just like as I'm here, I can go to America and back. How? In my imagination. So this complex number accounts for what happened long time ago when mathematical organizers had to say, if I have a plus b, you see that, sorry, if I have x minus 2 equals to 0, let's say this is x squared, you see that very well this is going to give me x squared equals to 2, and if you take the square roots, this crossing over will become x plus or minus 2, then you have the root sign. So you see that this is okay. If you punch it, it can give you something. But a situation can come where you have x squared plus 4 equals to 0. You see that very well, x squared, if 4 crossover, becomes minus 4. And taking the square root of both sides makes account for plus or minus root 4. And this root 4 is a negative root 4. A negative root 4. So you can very well see that if I have negative root 4, if you punch it on your calculator, root of negative number, it will tell you error. So what this is going to be is simply x is equals to plus or minus, I'll say root minus 1 times root 4. So the first letter of imagination, we now said anytime we have minus 1, we have root of a negative number. Simply say that that number is the same thing as saying root minus 1 times root 4. In this case, you see that it still gives you root minus 4. So in that case, we now say use the first letter of imagination, which is I, to represent anything negative 1 that is having a square root. So this is going to be I. Now square root of 4 is 2. So this is going to be simply the same thing as saying x is equals to plus or minus, I know it's I2, but let me write it well, 2i. So x in this case is going to be the same thing as saying plus or minus 2i. So if I know this, it gives account for what complex number is. So mathematically, we write complex number as the set of numbers with real parts and imaginary parts, such that a and b are the real numbers and I is equals to root minus 1. So we can say that I is the imaginary part. So we close it. We know that anytime we talk about set, we use curly brackets, we close it. So if I know this, with the understanding I have from this, I can now clearly see that whenever I have complex number, say of this form, whenever I have a complex number, it can simply be put, should I say that I here must be equals to a negative before I can talk about complex number. So you see that complex number makes account of including real numbers and also imaginary numbers. So we say that it is the chief of all the numbers. So please, we have given you 7 major types of number system: natural number, whole number, integer, rational number, irrational number, real number, complex number. So in our next class, we'll be solving questions under this. We'll be solving questions related to prime numbers, solving questions related to complex numbers, going deep inside each course. We have videos on each of these courses or each of these number systems that we've treated, and there where you find question on it. So thank you very much. Remember to like, share this video and subscribe. Bless.